Let's roll through review 7. It goes as quickly as possible, so I don't want to hold you up, but I do want to make sure I explain so you get something out of this as well. So the first one, which of the following is equivalent to cotangent over cosecant? Well, we know we got to convert to cosine and sine. Cotangent is cosine over sine. I'm leaving the theta out just to save time. Cosine over sine, and then divided by, so times. Now, cosecant is 1 over sine. We're going to flip that, though. That's going to be sine over 1. And then, of course, the sines cross reduce, 1, 1, and now you're left with just cosine theta, and that's choice 1. If the midline of a trig graph is -1, let's draw this out real quick. So if the midline's -1, let's call that the midline, and the amplitude is 4, so we're going to go up 4, down 4. 1, 2, 3, 4. 1, 1, 2, 3, 4. Again, this is -1 right here. -2, -3, -4, -5. You're going down 4 units. You're going to go down to -5. So anything, it says a minimum point, right? So anything where you're going down 5 or down to -5, so anything that's a -5 on your y, that's going to be a minimum point. So that's going to be choice D, 2, -5. Which function has a phase shift that would shift furthest to the right? These shift to the left. Remember, a plus actually shifts to the left, okay? Because it's x minus h, right? X minus whatever. So the pi over 6 is actually a negative pi over 6. That's a left shift. That's a left shift. These are right shifts. Now, pi over 4 is a 45-degree shift to the right, and a pi over 6 is a 30-degree shift to the right. So which one's further right? It's going to be the 45, or it's going to be the pi over 4 is further shifted to the right. That's B. Which of the following is an even function? I don't want to... I could show each of these. It would take a while on the graphing calculator. I did them ahead of time. The answer is B. You will have to type each of them into your calculator and look for symmetrical over the y-axis. So I'm going to draw this one for you. Okay, this B, this 2 cos x plus 3 is, I did all these ahead of time just to save you time. This one looks like this. Okay, sort of, kind of. But you see how it's symmetrical over the y-axis? If you fold along the y-axis, this lands exactly on this. Okay, it's doing the same thing on both sides of the y-axis. That's why choice B is correct. Now, so again, even is symmetrical to the y-axis. Odd is... You're going to turn it upside down, turn your calculator upside down. It's got to look exactly the same. It's symmetrical to the origin. Now, for these, see how it's pi over 2, pi over 2? You got to make sure you're in radian mode. Write this down. Radian mode, and then you will zoom trig. We've done this. Okay, you should know how to work the calculator by now. But just a reminder, radian mode, because they're going to give you pi in terms of pi. You can't type pi in degree mode. The calculator is going to think it's 3.14 degrees. It's not 3.14 degrees, it's 3.14 radians. So we got to make sure we're in radian mode when we're dealing in pi. Okay? All right, just going to get rid of that. All right, so here we go. Amplitude is 3, right? You disregard the negatives, absolute value. The midline is -2. The phase shift is pi over 3. Remember, it's positive pi over 3 because there's a negative there. You change the sign. The period is 2 pi over W. W is pi over 4. So keep change. We've done this a million times. Keep change, flip that, and you're going to get, the pi's are going to cancel. You're going to get 8. 8 is the period. And the frequency is the reciprocal of period. reciprocal of period, so reciprocal of 8 is 1 over 8. For the angles measuring 31, 35, and 240, express in radian measure and identify the coordinates of the points in intersection with the unit circle. So I already did this ahead of time to save you time. 30 degrees is pi over 6. And that's going to be the point radical 3 over 2, 1/2. You just go to your unit circle. Got to make sure you can produce the unit circle, right? 135 is going to be 3 pi over 4. And that's going to be negative radical 2 over 2, radical 2 over 2. Okay? And 240 is going to be 4 pi over 3. Okay? And that's going to be negative 1/2, negative radical 3 over 2. From your unit circle, you got to study that. Remember how to produce it and all that. If they give you the radian measure without pi, you're going to have to do it the old-fashioned way. Multiply by 180, divide by pi. All right, so you do that, and you should get 200.5. 200.5 degrees. All right? Hope I'm not going too fast for you or too slow. All right, we're going to fill in this table here on page 2. And I already did this ahead of time, so I just want to get you these. We got 3, right? 3, 2, 1 for the amplitude. Hopefully you did this ahead of time. Period is pi, 4 pi, and then 3. Remember, period, guys, is 2 pi over w. 2 pi over w. W is 2. W is 1/2. W is 2 pi over 3. So 2 pi over w to figure those out. Frequency is 1 over the period. Period, so 1 over pi. 1 over 4 pi. 1 over 3. And the midline is just the last number there. It says nothing there. It's a 0. There's a plus 0 there. And this is 4. And then this is negative 5. All right, we should know those by now. It's pretty easy. On the axis below, this was actually on a Regents exam. On the, oh my goodness. On the axis below, graph one cycle of a cosine function whose amplitude is 3, period is pi over 2, midline is 1, and it's got to pass through the point 0.4. So let's do that first. I got to go through the point 0.4. I need a midline of 1. Put my midline on there. My period is pi over 2. My amplitude is 3. Well, that works out good because my midline is 1, so up 3, right? Now, because the period is pi over 2, I can put that really anywhere I want. All right, I'm going to go 1, 2. What I did was I went 1, 2, 3, 4, 5, 6, 7, 8. I just did 8, and I made that pi over 2. So then in between right there, because this is 0, right? And then this would have been pi over 4. 1/4. This is 1/2 of pi. This is 1/4 of pi. And then boom, boom. You could keep going labeling if you want to, but it's not necessary. We only need to do one cycle. One cycle. So, okay, so if I'm at my max here, I got to be at my max at the end of the cycle. So the cycle's got to begin and end. It's cosine, right? So we begin and end with our max. Our minimum's going to be right in the middle. So what's right in the middle of 0 and pi over 2? It's going to be right here. Now, what's my minimum? I'm going to get rid of that. What's my minimum? Well, I go up 3. My amplitude says go up 3, so I must go down 3. Boom, boom, boom. Down 3. Right there is going to be my min. Right there is going to be my min. It's down 3 units from the middle of 0 and pi over 2. And then, of course, in between those, I'm going to have a midline point. And in between those, I'm going to have a midline point. We've done this. And I'm just going to sketch smooth curves the best we can. That wasn't great by any stretch of the imagination, but I told you it's not easy to do, but I can do better than that. There we go. There's one cycle one cycle of my cosine curve, 0 to pi over 2, amplitude of 3, midline of 1. Okay, just got to make sure everything works, and it does. Parts 3 and 4 here. We're going to do a radical graph, so make sure a radical equation. So, got to isolate the radical. So a little throwback here. Subtract 1. Oops, just subtract 1. So it'll be x minus 1. Now, square both sides. That's going to be x plus 11. And this is going to be x minus 1, x minus 1. So that's going to be x plus 11 equals x squared. You could do a table here, tabular, whatever you prefer. It'll be minus 2x plus 1. So get it equal to 0. It's going to be 0 equals x squared minus 3x minus 10 when you bring those to the other side. Factor. X equals 5. X equals negative 2. Now, when you check, you have to check. You have to check these. I'm not going to check for you. You should know how to check by now. I want to save you time in the video. The 5 works, the 2 does not. So I'm going to do that, and my solution set is fever 5. Page 3. Use the reverse tabular method to find the quotient. So reverse tabular, you're going to need a 3 by 2 for this one. 3 by 2. Alright, so I got x minus 4. I got, this is going to be x to the third here. This diagonal is going to be 3x squared. This diagonal is going to be negative 30x. And this diagonal is going to be 8. Alright, so I got x to the third goes there. This is x squared. This is minus 4x squared. This diagonal's got to add up to 3. This has got to be 7x squared. So that's got to be 7x. Negative 28x. Negative 2x. Negative 2. And 8. Alright, slow that down. Review it again if you need to. Your final answer is going to be x squared plus 7x minus 2. Now, number 12 is a graphing calculator one. Hopefully you did it in class because you probably don't have one at home. Basically, you're finding your max, your min, and your zeros where it hits the midline. Those are the zeros. So I'm gonna tell you the keystrokes here, right? So you're gonna go y equals. Then you're going to type in the equation, 6.14 sine 1.4. Literally type it in exactly how you see it. Okay, now, what do? Second trace. Okay, second trace is the calculate menu. That's the calculate. Go to, for the max, you go to max, right? So go to max or min or 0. So it's max, min, 0. Whatever you want. Max, min, or 0. And then do left bound, right bound, and then guess. Just like every other, we've done this. We've done it a million times. I'm just going to give you the answers. Hopefully you did this ahead of time. If you didn't, I don't know how you're going to do it. You kind of cheated yourself a little bit. 3.22, 9.54. The min should be 0.98, negative 2.74. Or, there's two mins, 5.47, negative 2.74. Then there was some zeros. There were 4 zeros. You could have had 4.760. These are the midline points. You could have had 6.170. You could have had 1.680. You could have had 0.280. Okay, obviously 0 is the zeros. Negative 2.74 is the minimum value, but these are where they occur, where those minimums occur. And then 9.54 was the max value. 3.22 is where the max occurs. All right, last one, our trig graph application, which we just did, right? We just learned recently. The Acme company in Walla Walla, Washington has developed a new cell phone case that can withstand extreme temperatures. Acme decides to put this case through a rigorous test. At the beginning of the test, the case is placed in an environment where the temperature is 70 degrees Celsius, so it starts out at 70 degrees. 5 minutes later, the temperature drops to negative 30 Celsius, so extreme heat, extreme cold, and then 5 minutes later, the temperature increases to 70 Celsius again. So we're going extreme heat, extreme cold, extreme heat. This pattern continues for a total of 30 minutes. Create a graph from 0 to 30 minutes. Determine the equation of the function that models this test. So we know what's going on here. We're going from 70 to negative 30. That's going to be our max and our min. So I'm going to have to go by tens here, right? This is going to be 10, 20, 30, 40, 50, 60, 70. I'm just going to label 70, and they're each 10. You could just label, you don't have to do every single one. And this is going to be negative 10, negative 20, negative 30. Negative 30 right there. All right? So that's the y-axis is the temperature. The time, 30 minutes. So we're going to go to 30. We'll go by fives. Or we'll go by ones, actually. 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's going to be 10. 1, 2, 3, 4, 5. This is going to be, wait, 1, 2, 3. That's not right. 1, 2, 3, 4, 5 right there is going to be 15. 1, 2, 3, 4, 5. 20. 25. 30. And that's because we need 30 minutes, it says. Now, it started out 70 degrees Celsius. So we're going to start there on the y-axis. Plot that, 70 on the y-axis. Now, 5 minutes later, it went down to its minimum, which was negative 30. So at 5, you got negative 30. 5 minutes later, it went back to 70. 5 minutes later is 10 minutes. It's back to 70. See the pattern? Okay. Now, what's my midline? Before I continue, I want to do my midline. 70 to negative 30 is 100 degrees. 100 degrees divided by 2 is 50 degrees. So that's not the midline. That is 50 degrees from the top. 50 degrees down, right, is going to be the midline. So that's going to be a 20. Okay, so my midline is 20 degrees. It's 50 degrees from the top and 50 from the bottom. So I know 5 minutes later, so then the same pattern, right, continues the same pattern. Down, up, down at 15, up at 20, down at 25, up at 30. Okay? Down, up, down, up. Now, in between a max and a min is going to be a midline point. We know that. So we're going to have midline point at 2.5 minutes, at 7.5 minutes, at 12.5 minutes, 17.5 minutes, 22.5 minutes, 27.5 minutes. There's all my midline points. And now I'm going to just connect using my knowledge of sine and cosine curves. Oh my goodness. What a disaster. That's really bad. I can't leave that. Slow down. And Hopefully yours looks something like that, without this little jagged little whatever it's going on right here. There we go. Okay, so there's our graph. And the function, I'll call it T of x. T of x, okay, temperature, right? X is time. 50 is the amplitude, from 20 to 70. So 50 is the amplitude. This gave us the amplitude right there. Cos. It's a cosine curve because it starts at the max and then goes down, right? So it's a cosine curve. We know it's going to be something x. And then the midline is 20, so plus 20. Now, the only thing we didn't figure out is we did not figure out the W value. So the period is a full cycle, so the period is 10. There's one full cycle. Takes 10 minutes to make the full cycle. If the period is 10, W is 2 pi over the period, 2 pi over 10. I could put 2 pi over 10 in there, but I know 2 over 10 reduces to pi over 5. I mean, 2 over 10 reduces to 1 over 5, so I know this is pi over 5. So 50 cos pi over 5x plus 20, and that is it. And I will see you in class for the quiz tomorrow.